All attendees are in listen-only mode.
Welcome, everyone. I'm Vaishali Jain, and I'll be your moderator today. And thank you for joining us here at NetCom Learning. As a company that provides training, learning, and talent development solutions and wants to promote lifelong learning, we're happy to host today's webinar on big data's application in the business environment. And presenting today's topic is Vincent Suppa. Vincent is an NYU graduate professor, SPHR certified, and has his certified executive Six Sigma Black Belt, and is the founding president of HR Avantgarde. Today's session is being recorded, so you will get free access to the recording in the next 24 hours. A PDF of today's slides will be posted in the questions pane over here. I'll go ahead and do that in just a moment. We'll also give you a quick overview of the logistics before we get started. To start with, everyone's been muted except for our presenters, and we welcome all questions. You can go ahead and type them in the questions pane, and we'll address them at the end of the webinar. And you also have the option to adjust the window size to your liking. Simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer over here. And without further ado, I'll go ahead and hand it over to Vincent.
Thank you so much. It is my pleasure to be here. The goal of this presentation is I want everyone to be able to leave with at least one piece of operational advice, hopefully more, that you could immediately begin using to improve the quality of your professional life. Just to put the presentation in context, oil was considered the currency of the industrial economy. In that same vein, data is now considered the currency of the knowledge economy. We're going to talk about a couple of impacts. Firms are now relying less on their own internal data and more on external data from social media. People also claim privacy concerns while simultaneously volunteering troves of data to other companies. And what we also find is that the ability to learn, which means to be nimble, is now valued more than actual experience, and we'll explain why. Intuition now becomes less critical as decisions are more data-driven. Let's begin. Now, on the left of your screen, we're looking at all of the different waves that led up to big data. Businesses first developed metrics, then benchmarks, and then dashboard indicators, and then many firms, but not all, have gone further to predictive analytics, and then finally big data. And just to put the trends of data is being aggregated in context of technological revolutions, we see how in the past 5 decades we've gone from mainframe computers to PCs to the internet, both 1.0 and 2.0, to big data, and then the next trend after big data will be the Internet of Things, just as a preview of things to come. Now, let's be mindful of the distinction between big data and traditional analytics. Big data is characterized by not being able to be handled by standard software and databases. There are a couple of characteristics of big data. One is the volume of data. Big data, which is self-referential, really refers to a lot of data, but it really goes beyond that. Big data also refers to a variety of unstructured data. It could be anywhere from open-ended engagement questions on business customer surveys to the number of likes on Facebook. Because big data comprises a variety of unstructured data, this is the most challenging because it is not scalable. And next, we go to the velocity of data, and that refers to 2 characteristics. The velocity of data, characteristic of big data, refers to the increasing rate of real-time streaming data. That is how fast the data is coming to us, and also the speed at which that data must be evaluated to still retain its value before it becomes obsolete. Now, let's look at a little bit of structured data versus unstructured data. Structured data is what we've been using, what businesses have been using for decades. Standard relational databases with linear analysis and binary data definitions. But unstructured data really refers to the host of social media that we use in our everyday lives. So it contains free-form qualitative information. Social media posts, blogs, wikis, emails, expense reports. even images and video. So that's why unstructured data is not scalable, because it encompasses such a variety. Now, of all the data that businesses are using, some of them are internal and some of them are external. So if you just look at this list, many of the things on this list are internal, transactional systems. Companies could be using Oracle, SAP, JD Edwards. Basically, they're ERP systems, they're resource enterprise systems. That would encompass internal data, but now companies are accessing external data to merge with their internal data to help them make better decisions. And that includes social media sites, LinkedIn, Facebook. And I want you to be mindful of digital exhaust. Digital exhaust refers to so many things that we might not be cognizant of. For example, companies could know how many 18 to 34-year-old males pass a sushi shop during lunch hour but don't go in. Right, that would be the digital exhaust from the GPS device from iPhones, or even the number of unfulfilled orders on Amazon where customers just leave a cart without actually converting to a sale. So there's a lot of digital exhaust. And of course, the Internet of Things, which is just starting, is going to add even more data to the theater of big data. And just for anyone that may not be aware, the Internet of Things refers to low processing embedded chips that have devices automatically speak to other devices. Now let's look at the internal side of big data. That generally comes from companies' ERP systems. You could have marketing modules, HR modules, supply chain modules. It's all of the data that's housed inside of the company. Now, external side of big data refers to all of the data that companies need to access, but they exist outside of their ERP system. It would include other vendors, perhaps ERP systems, but it would also include LinkedIn and the various other social media sites. Now, the first thing I want to mention is that a lot of companies access big data by simply taking inventory of the data they already collect. This is different from traditional analytics, where companies might decide that they need to collect data specifically to drive a decision. But with big data, we're taking inventory on what is already there. Now, I'm going to give you a couple of examples of the application of big data, and then we'll drill down to some more specific examples. There's a defense company, and they train thousands of employees in the latest technology. So they use internal data in their ERP system and external data to determine the best return on investment of training locations. And the dependent variable was which had the least expensive cost. They looked at external data that told them hotel cost, flight cost, forecasting locations, and they had their internal data, which would be how much they would pay for the instructor and where's the physical location of their own employees, because that would determine how much they would have to spend on airfare. Another application of big data is in Silicon Valley. There's a firm that specializes in network infrastructure products, and they use LinkedIn to track and analyze the skills, knowledge, experience, and career paths of both their employees and their former employees and potential employees. So instead of looking at their own internal employee database, instead of looking at their own recruitment module, they're actually looking at the knowledge, skills, and abilities of current and potential employers that they may want to tap on the shoulder by what they post on LinkedIn. And finally, another application of big data would be for a global courier delivery firm. Here they use big data to make M&A decisions. What they do is they analyze the aggregate workforce data of the company that they wish to acquire. Now, often they don't have access to this company's internal ERP system if they're looking to possibly acquire it, but so much of a company's data exists outside of the firm that this company is able to aggregate that data on social media before deciding to go forth on a merger and acquisition. Now, here's a little bit of operational advice. How could you use the information I'm giving you? Well, first you want to determine what decisions do you want to make from big data. The second point is you want to take inventory of the data you already have. You want to inventory data that's internal and data that's available outside of your firm, most likely on LinkedIn. And then you want to determine the dependent and independent variables for the hypothesis that you want to test. And then my favorite is you could contract STEM graduate students, that's science, technology, engineering, mathematics, and actually turn them into data scientists. A lot of my clients say, well, we don't really have any data scientists to help us actually implement big data. And I say, you know what, you should contact universities and you could find current graduate students and they could actually assist you in that application. And I always say that to learn coding, there's so many free online courses, and many of us are not going to be professional coders, but because coding is becoming the new literacy, it just empowers us to have an even better conversation with the coders that do ultimately work for us. Now, just a quick review. An independent variable is the variables that you're going to manipulate. Those are all the data points that you're taking inventory of. And the dependent variable is the measured response or result that you want to happen. Now, big data's impact is that intuition is going to be less important than a data-driven decision. So traditionally, executives get paid a lot of money for their experience because they've developed a gut feel based on that experience. But with big data, it's going to be the data that drives decisions and not intuition. So it's like seasoned professionals versus quantified data-driven decisions. Now, some of the impacts of big data: the data is not clean or structured, something that we referred to in last month's webinar. The signals from big data are usually not strong, and it involves continuous process improvement, which can have a great impact if big data becomes an endemic part of your culture. And then the number of systems providing data go from dozens, which might have been the dozen modules inside of your ERP system, to now thousands. Now, two trends we're going to highlight are the ratio of external to internal data is high, and how the volume of big data now will require a data warehouse. Now, the reason why the ratio of external data to internal data is high, one illustration of that is that firms with internal skill set databases, they report that their own employees are more conscientious at updating their skill sets on LinkedIn before they even do so on their own internal company's database. So that's just one illustration why external data is becoming even more important than a company's own internal data. And because data is at such a high volume, it now requires a data warehouse. And I use the illustration of a pizza. You could think of a pizza slice as a data mart and the entire pizza pie as a data warehouse. Now, a data warehouse, and this is just at a very high level, but it extracts data from the source, it transforms the data for storing, and then you have the data loaded into a data mart. This allows you to make analysis on the data mart without impacting your live production database. And we could possibly drill down on this in subsequent webinars. Now, what might big data look like at the C-suite? Well, we talked about dependent and independent variables based on the hypothesis that you want to test. Well, once you determine the leading indicators that cause the results that you want, you could present them as dashboard indicators that are fed possibly on a daily basis, or for some companies on a real-time basis. This makes it very easy for executives to view sensitive changes in their own companies. Now, dashboard indicators, they provide at-a-glance views of relevant key performance indicators, and they're usually very visual, and they're typically limited to aggregate summaries. Because remember, a dashboard indicator is at a very high level, but also if you're just the department head of your own department, you can have your own dashboard indicators for the leading indicators that are important for your job. Remember, your lagging indicator, whatever you're being paid to perform, is usually someone else's leading indicator within the enterprise. Now, some of the elements of a dashboard indicator is sophistication and simplicity. So a dashboard indicator might have only a couple of numbers. Indicators, of course, should not correlate, because if they do, they're simply telling the same stories. And it applies visual perception to the information that is being presented. And this is just a quick visual illustration of what a dashboard indicator might look like. And there are many software applications that could help you aggregate the data in such a visual manner. Now let's drill down to some very specific examples. There's a financial planning firm, and instead of push recruiting, they're reverting to pull recruiting. And what they do is they cross-pollinate their current employees on their own ERP system, and they also looked at those same employees' LinkedIn external data, right? So they're really looking at historical benchmarks. They're comparing their own employees, what they post on their own internal website, and what those same employees put on LinkedIn. This was done to test multiple hypotheses on what traits, which would be the independent variable, what would those traits be that cause the dependent variable, which they define as on-the-job success. By looking at employees that are already successfully working for the company, they found that the most successful employees already had a family member working for the company, were very entrepreneurial, they had previous connections to large companies, and they did a lot of volunteer work in their community. So these were predictors for employees that were already successful in the company. So what they did was they then tapped on the shoulder potential employees on LinkedIn that were not even looking for a job, that exhibited the same traits, and consequently they were able to have a higher penetration rate in getting candidates who did not even know they would be interested in working for the company to now be interested. Now remember, as we alluded to last month's webinar, which is archived, big data is not about causation, it's about the correlation. So this firm that we use as an example, they're developing a model to use against external and internal data to resolve the dependent and independent variable for the hypothesis. And that hypothesis is these traits cause successful employees. And so with pull recruiting, it has a direct application on reducing the cost of hiring, which of course is going to increase net income. Another example is a firm conducting correlation studies between what employees say on their own internal surveys and what they post on external social media. So you could have someone from company A, an employee attitude survey, they say the company is wonderful, but then on social media, they actually have very harsh things to say about the company. So possibly they don't trust the anonymity of an internal employee engagement survey. So what this company tried to do was determine what, if any, discrepancies were there about what their own employees were saying about their firms and social media against what they were saying on internal employee engagement surveys. Now there's another model being developed where you can create an attrition model capturing 30+ data points which could predict months in advance with high correlation which employees are going to resign for better offers within the next year or two. Now, here's some operational advice, something you can immediately begin using to improve the quality of your professional life. If your firm is not ready to execute big data analytics, here's something that you can do now. Take an inventory of the data that your firm already collects and data that you would be interested in aggregating from external social media. Write the hypothesis you'd like to test. Then list the data or the variables that would test your hypothesis. And then you can also list additional data perhaps that you don't currently collect, but if you did, it would really you'd be able to test the hypothesis that much better. The reason why I recommend these 4 action steps if your firm is not ready to execute big data, because even if your firm never goes forward, you now have a solid resume bullet point on what you've accomplished so far preparing your company for big data. And that's it. If you're interested in any other events, big data, or in startup companies using big data, you can go to the event page on hravantgarde.com. Thank you so much.
Thank you, Vincent. That was really informative. And we now welcome everyone to send in your questions for Vincent, and we'll give everyone just a few moments to get those in. In the meantime, I'd like to direct your attention to our website, netcomlearning.com, so I can tell you about some of the other free webinars that we have coming up. If you scroll down here, you'll see free webinars. You just click here, and you'll see all of them that are coming up, and you can enroll for as many of them as you want. And If you scroll down further, you'll see the recently completed webinars, and this is where you can access today's recording, and we'll have that ready for you in the next 24 hours. We also offer a host of other business and IT courses, which you can click on to see over here, as well as certifications. And there's a number of promotions that are running right now, including $500 off on a PMP course, as well as an upgrade when you attend Windows 7 or 8 training. In addition, there's a savings on the CompTIA certification exam when you purchase a CompTIA test voucher from NetCom Learning. Okay, we have a couple of questions, Vincent. One is, I'm a non-technical person. Do you recommend I try and learn coding anyway?
Well, I do. First of all, the cost to learn coding is very low. There are many free courses on the internet where you could learn R, for example. There's a lot of online courses, and even if you decide that you're not going to be a professional coder, we did mention before that it really is becoming the new literacy. In fact, a lot of younger people in grammar school, there are many schools that now offer coding the same way that you and I learned how to read and write with the alphabet when we were younger. So taking a coding course might not make you an expert coder, and you might not be interested in that, but it will empower you to have even better conversations with coders that might possibly be working for you. So yes, I do recommend it.
Okay, there is another question. If you don't have any coding experience, what courses or coding language do you recommend?
I recommend R because it is free and it's one of the most common. Python is another one that I recommend, but I would recommend R because it is free. So I would start with that. And once you start learning it and you build momentum, it's never as scary as what we might think it is when we know nothing about it. So it's just a matter of building up some momentum and building up confidence, and you'll see you'll be well on your way. You just have to take that first step.
Okay. There are several questions about accessing the presentation today, so I've gone ahead and just copied and pasted it into the chat box.
Excellent,
okay.
Thank you.
And there is another question. How do various big data solutions like Hadoop versus Cassandra, MongoDB compare? Do you have any material to compare?
No, I don't really want to, advocate one company over another, and I'll tell you why. The rate of change is so rapid. If one company has a slight advantage, that advantage could easily be obviated, a couple of weeks or a month later. So I would say that it depends on what specifically you want to accomplish, and then actually meeting with representatives of these companies and being able to compare. But at a very, very high level, without knowing the specificity of what hypothesis you're trying to resolve, I don't really want to advocate one company over another, but I would say check all of them out, and it'll give you some type of benchmark.
Okay. And is Hadoop needed to learn your training?
Can you repeat the question?
Is Hadoop needed to learn your training?
Is it needed to learn as part of a person's training?
Yes.
It's a choice. You could be trained without that, but being trained, with Hadoop is just another tool in your toolkit and can only be to your advantage. But it's not that everyone that uses big data 100% know Hadoop. But yes, it would be another tool in your toolkit, but not the only one.
Okay. Somebody is asking about various solutions around Hadoop, like Pig, Hive. Do you have use cases for the various solutions?
No, I would really have to know the specificity of what a client wants to accomplish. So at such a high level question, I don't really have a specific question, a specific answer.
Okay. For people who aren't getting specific answers, and if you need a little bit more of a drill down, you're welcome to send any questions or requests to webinar@netcomlearning.com as well. And just to clarify from an earlier question, Vincent, are you recommending our course for coding, the R course for coding?
Yeah, R is a programming language, and it is free, and it's one of the first coding languages that many amateurs decide to learn. So I do recommend that. And it's certainly not the only one. And I don't have the answer. I simply have a point of view. But I would also speak to peers, get informational interviews with people that actually do code and get their opinions as well, because I'm just one voice out of many. And that way you can make a good assessment comparing what I say and what other people in your network might recommend.
Okay. Would you be able to tell us about any other programming languages in big data other than R?
Python, I might recommend. But also, all this information is accessible. I would first get informational interviews with coders, ask what they possibly recommend. But also, you want to know, do you want to be a professional coder? Because if so, you might want to learn other languages. Or if you just want to develop some coding literacy so you could have great conversations with coders, then you might be interested in R and Python. So it also depends on what do you wish to accomplish with the skill, professional coder or being able to speak the language of coders.
Mm-hmm. And is SAP required to complement someone's training?
Well, there's never any requirements. I mean, I'm going to say that big data is also not a quote-unquote requirement. It's just one of the most powerful tools in your toolkit. So there's not one thing that is a do-or-die requirement, but each of these things add up SAP. It's another tool in your toolkit. But also, it depends on the specificity on what you wish to accomplish. And also, if you're already working for a company, what is the coding language that your own technologists are currently using? Obviously, you might want to either complement that language with learning another one or integrate yourself with that department by learning the coding language that might possibly already be endemic in the company that you work for. So these are good questions to ask.
Mm-hmm. Okay. And can you talk about how to dive into big data domain for business analysts, particularly for business analysts? Is it really worth studying big data for business analysts? What are your thoughts?
Yes, because experience is mattering less and data to drive decisions matters more. And an example would be, imagine the executive with 40 years of marketing experience in 2008. Well, keep in mind, he might have 40 years of marketing experience, but 90% of that time was before social media. So the quote-unquote experience that might be worth more than 40 years of marketing experience in 2007 might be a younger person who grew up with social media and might only have 3 or 4 years experience, but embedded in social media. So what you're going to see is that people, the comp plans should adjust, that data scientists' comp plans possibly would increase, and just because someone has 40 years experience in a field, that might not be worth what it used to be worth, because now data could drive the decisions instead of a seasoned professional's gut feel. So one way to dive into it is to learn some coding so you're familiar with the language, take inventory of the data, because there are many things that you can do that are qualitative soft skills before you even get to the coding. Decide what decision you want to make. Take inventory of the data and write in plain English what is the hypothesis that you want to test, and then you could partner with STEM graduate students at local universities and synergize with them.
Mm-hmm. Okay, we have one more question. I don't know if you'll have time to answer it or if it's in the scope, but can you throw some light on big data of insurance organizations who totally depend on data?
Well, I think that big data should be able to improve the performance of insurance, because insurance is all about statistics, actuary tables, and really based on the theory of large numbers, being able to know how many people are going to possibly suffer from a flood. The problem is that they don't know which people will, but with the theory of large numbers, they know what percentage would. And I think big data offers even more variables, and insurance companies would be able to predict with even greater accuracy what people might possibly suffer from different incidences that they are being insured for. So I think insurance companies will improve their performance because of big data.
Okay. Fantastic. Okay, well, it's now come to the end of our webinar. And Vincent, do you have any final thoughts?
No, it was a pleasure to be here. I will say that there's a webinar from last month that is archived, which talked about big data from a foundational point of view. And if you were to listen to that archive, it might put this webinar in better context.
Great. Okay. Well, thank you all for joining us today, and thank you very much, Vincent, for that very informative webinar.
Thank you. My pleasure.
If you come up with any questions in the meantime, please feel free to send them to webinar@netcomlearning.com. Okay, thank you.
Thank you. Good afternoon, everyone.